Welcome to qnawire.
So here in this problem we are given this truss and we have to calculate the force in each member, and we have to also state whether the member is in tension or compression. So to solve this problem we'll be first calculating the reactions, that is AX, AY and GY. So for that we'll be using equilibrium condition. The first one is sigma Fx is equals to 0. Now we have only one force in X direction. This one is X direction and this one is the Y direction. So we have AX only, and that would be equals to 0. Now next we'll be considering the equilibrium forces in Y direction. So sigma Fy equals to 0. Now the forces in the upward direction will be taking positive and the forces in the downward direction will be taking negative. So we have AY plus GY minus 6 is equals to 0. So from here AY plus GY would be equals to 12. Now we can take moment about point A. So sigma MA should be equals to 0, and the moment in the anti-clockwise direction will be taking positive and the moment in the clockwise direction will be taking negative. So we can take the moment now. So this is making moment in the clockwise direction, so minus 6 times the perpendicular distance is 18, again minus 6 times 18 plus 18 is 36, this total distance is 36. Now plus GY times 18 into 3 is equals to 0. So from here GY comes out to be as 6 gips, and we can plug GY here to calculate AY, and from here AY would be equals to 12 minus 6 is 6. Now we have calculated all the reactions. Now next we'll be considering the free body diagram of the joint A. So this is the free body diagram of the joint A. Now we have to calculate the force in the member AB and AC. Now we have assumed that the forces acting at joint A would be like this. That means the member would be in tension. Now if the value comes out to be as negative, that means our assumed direction is wrong and the member would be in compression. So let's find out the values. For that we'll be considering the equilibrium condition. The first one is sigma Fy equals to 0, and we'll be following the same sign convention as we followed earlier. So we can write, we have to take the vertical component of the force FAB, so it would be 4 by 5 FAB plus 6 is equals to 0. So from here FAB comes out to be as minus 7.5. Now here minus sign denotes that our assumed direction is wrong. The direction would be like this. That means the member would be in compression. So we can say that FAB will be equals to 7.5 and the member would be in compression. Now next I will be calculating FAC. For that we can use one equilibrium condition, that is sigma Fx is equals to 0, and the forces in this direction will be taking positive and the forces in this direction will be taking negative. So we have FAB, we have to take the horizontal component of this force, so 3 by 5 plus FAC would be equals to 0. So 3 by 5 FAB we have calculated as 7.5, means 7 minus 7.5. So minus 7.5 plus FAC would be equals to 0. So from here FAC comes out to be as 4.5 kips, and since the value comes out to be as positive, so the member would be in tension and our assumed direction is correct. So these are the two forces in the member AB, and the next one is the member AC, and the direction would be like this. In AC it was correct and in AB it would be like this. Now next I will be considering the free body diagram of the joint B. So this is the free body diagram of the joint B. Now we know that force in the member AB, it was compression, the member would be in compression, so force would be acting like this. Now next we have assumed that the force in the member BD would be like this. The member would be in tension, and here also we assume that it to be like this. That means the member would be in tension. Now here if the value comes out to be as negative, that means we can conclude that our assumed direction is wrong and the force the member would be in compression. So let's start. For that, again we'll be using the same equilibrium condition. The first one is sigma Fy equals to 0. So we have to take the component of FAB in the vertical direction. So it would be 4 by 5 times FAB is 7.5 kips, then minus 4 by 5 FBC is equals to 0. So from here FBC comes out to be as 7.5, and since the value comes out to be as positive, so we can say that the member would be in tension. Now next I will be considering the next equilibrium condition, that is sigma Fx equals to 0. So we have FBD plus 3 by 5 FBC plus 3 by 5 FAB, that is 7.5, is equals to 0, and FBC we have 7.5, so we can plug it here, and we have only one variable now, FBD, and from here FBD comes out to be as 9 kips, and since the value is negative, that means the member would be in compression, so FBD would be equals to 9 kips and the member would be in compression. Therefore the direction of force in the member BD would be like this. Now next I will be considering the force on the joint C. For that I will be making the free body diagram of the joint C. So this is the free body diagram of the joint C. Now here also we'll be using the equilibrium condition. The first one is sigma Fy equals to 0. Now we will be taking forces in the y direction, so we have 4 by 5 times 7.5 plus 4 by 5 times FCD, that we have to calculate, minus 6 would be equals to 0. So from here FCD comes out to be as 0. Now next we'll be considering the forces in x direction, so sigma Fx equals to 0. So we have FCE in the x direction minus 4.5 minus 3 by 5 times 7.5 is equals to 0. So from here the force in the member CE will get this value as 9 kips, and since the value comes out to be as positive, that means the member would be in tension. So now next I will be considering this section. Now if you see this section carefully, we can say that the truss is symmetric about this section, and thus we can write that the force in the member AB would be equals to the force in the member FG, and this thing we have calculated earlier as 7.50 kips, and the member would be in compression. Now next the force in the member AC would be equals to the force in the member EG due to symmetricity, so it would be equals to 4.50 kips and the member would be in tension. Similarly FBC should be equals to FEF, and that is equals to 7.5 kips and the member would be in tension, and FBD should be equals to FDF, and it should be equals to FBD we have calculated earlier as 9 kips and the member would be in compression. And finally the force in the member CD should be equals to force in the member DE, and that is equals to 0. So these are final results. I hope you have understood the problem. Thank you.